Hello and welcome. This is going to be our homework help video for the linear inequalities from standard form homework. Let's go ahead and get started with problem number 1 here. Write the slope-intercept form of the equation of each line. Let's remind ourselves what slope-intercept form is. That is any equation of the form y equals mx plus b. We need to rearrange this equation here so that x just has a coefficient, there's a constant after it, and y is by itself on one side of the equal sign. This form right here actually has a name. It's called standard form. And converting from standard form to slope-intercept form is a pretty common problem in Algebra 1. So let's get used to this technique. It's almost the exact same every time. We start by moving the 8x to the other side. We want to move it away from our y because we want y to be by itself. After I move it, in this next step, I've got a choice. I could put it in front or behind this constant, this negative 8x. I'm going to put it in front of the constant so that it looks more like mx plus b. I can then divide everything by negative 5. And I divide every term by negative 5, which gives me the equation y equals, the negatives cancel out here, and I'm left with 8 over 5. And the x can come out in front, just like it is in mx plus b. And then the negatives cancel out here, and we could turn this into a decimal, but I'm also fine with us leaving it as a simplified fraction. Most of the time, I think that that's fine. Either way works. And so there's our answer for number 1. Let's do another one of these. We'll do number 4. Looks maybe just a little bit different, but the process is still very similar. Move the 11x to the other side by subtracting 11x from both sides. Put it in front of the negative 28, so I get negative 11x minus 28. Divide every term by 4. I'll get y equals negative 11 fourths x minus 7. That can be simplified down to just a 7. All right, and now, what's great about this is I can just clearly see what my slope is and what my y-intercept is. Makes it very easy to graph. All right, on to the linear inequalities. We'll do several of these so that hopefully you can finish them up on your own. Very first thing is this is difficult to graph. This would be easier to graph if it was in slope-intercept form. So what I'm going to do is first just copy it down where I've got some space. You should do that too if you're following along. And then I just want to do kind of the same steps as I was doing above to get y by itself. So I'm going to subtract 8x from both sides. Again, choosing to put it in front of the 5. So I get then, now y is less than negative 8x plus 5. And now this is easier to graph because I can clearly see what my b value is and what my m value is. That's my y-intercept, that's my slope, and I can just put those right onto the graph. I start at the end, I start my y-intercept, I put a point at 5. I then go down 8 for every one I go over. I could turn this 8 into a negative 8 over 1, so that means go down 8, right 1. Down 8, right 1, I'm off the graph. Now just leave these as 2 dots for a second while you think, do I want to connect these with a solid line or a dotted line? This symbol right here is just a less than, meaning we don't include the line itself as part of our solutions. So it's a dotted line. And just so you have that, let's write that on the side of our homework so we can just always remember. Less than, greater than, those are dotted. Less than or equal to, greater than or equal to, those are solid. And while we're at it, less than or equal to is to shade below. Less than, lower, and greater than or equal to tells us to shade above. All right, let's see which one of those do we have in our simplified form. We have a less than, so we want to shade below. So pick a point in your line, go down from it. We're into the lower section. That's the side we want to shade. And you could do this with a highlighter or something to make it a little bit more fun. Do a little better job there. or just the side of your pencil, and just shade it in lightly. All right, and then what we want to do to make sure we shaded correctly is pick a point over here and plug it in. I'll just pick 0, 0. That's definitely in my shaded region. If I plug that in, I'll get the equation 0 is less than 5 after simplifying this, and that is true, so we double checked. All right, y is greater than negative 1. Let's think about that for a second. So this isn't really a slope-intercept form. We use an acronym HOI-VUX to graph these really simple single variable equations. Y equals means that we're in the HOI part of this, and what this stands for is horizontal lines have 0 slope and they are of the y equals form. So this is going to be a horizontal line, and where is it going to hit? It's going to hit at negative 1. So I can dot this in across the graph. These are all the values where y is equal to negative 1. Then I ask myself, solid or dotted? Compared to this over here, I would see that I want a solid line. Oh, it's dotted. I want a solid line. There we go. And then do I shade above or below? I look at this and I see that I want to shade, it matches this one, shade above. Shade above. All right. So this region up here. All right. And that's what that one looks like. Those are all the values for those are all the points that have a y value that's greater than or equal to negative 1. That's what we just represented. Let's pick one of these that looks like it's going to give us a fraction. Number 7. I think it's a good one. Copy down with some space. Want to get y by itself, so I subtract 2x from both sides. I need that 5y is greater than negative 2x minus 15. Divide everything by the coefficient of y. Get that y is greater than negative 2/5 x minus 3. Now let's go to the graph. To graph that, start at its y-intercept of negative 3. To get to my next point, I use this slope here. This slope here is telling me down to right 5. Down to right 5. Or I could reverse that but I gotta reverse both of them, so go up to left 5. And we see that keeps us on a straight line. Now what type of line do I want? Compared to my tables, I'd see that this symbol tells me dotted. So dotted line to connect the dots here. Shade above or below, this is a greater than symbol. Greater than means shade above. So we'll shade up here. Here are all the ordered pairs that could make that top inequality true. All right, on to the back side. I'm looking for a special type of problem. I actually see 3 examples of it where we've got a minus in front of the 2y. So in this problem here, this problem here, this problem here, let's see if we have any more. In these 3 problems, you have to remember to do the following. And I'll do it once. You got to remember the other 2 times. I'll do number 9. So in the process of getting y by itself, you reach a specific step. You reach a step where you have to divide by a negative. So this is a big deal. You're dividing by a negative. This changes the truth value of that inequality in the middle. All right, and we can think about this. If I've got 1 is less than 2, if I divide both sides by negative 1, I would get that negative 1 is on the left side and negative 2 is on the right side, but negative 1 is the bigger number than negative 2. So our inequality must flip directions when we divide by a negative. So really key, right there, I flipped the direction of that inequality. If you don't do that, you're going to shade the wrong side. But hopefully you would catch that when you check with your double check. All right, point at 3, go up 3 over 2, or down 3 left 2, down 3 left 2. Left 2, I've got my line dotted in across the graph. I pick a solid line to connect these. And then, because I flipped this and now it's a greater than symbol, I'm going to shade above. Shade up here. All right. So don't forget to do that with 10 and 11. You will divide by negative, and you'll need to do this very important step right here, where our inequality flips directions. Let me see. I think the rest of these should be easy enough. So good luck finishing that up. Have a good rest of your day.